Hello everyone, my name is Dinesh and my roll number is 536. Is implementing precise interruptions in pipeline process. Most computer architectures are based on a sequential model of program execution in which an architectural program counters sequences through instructions one by one, finishing one before starting the next. The use of sequential architecture and a pipeline implementation clash at the time of an interrupt. The process state generally consists of the program counter, registers, and memory. If the saved process state is consistent with the sequential architecture model, then the interrupt is precise. Classification of interrupts. We consider interrupts belonging to two classes. First one is program interrupts, sometimes referred to as traps, result from exception conditions detected during fetching and execution of specific instructions. These exceptions may be due to software errors, such as trying to execute an illegal opcode, numerical errors such as overflow, or they may be part of normal program execution as it page faults. And second one is external interrupts are not caused by specific instructions and are often caused by sources outside the currently executing process, sometimes completely unrelated to it. For input for input and output and in timer interrupts, a precise process state makes restarting possible. Unimplemented outputs can be simulated by system software in a way transparent to the programmer if interrupts are precise, where pipeline information is dumped at the time of an interrupt and stored to the pipeline when the process resumed. A parallel pipeline implementation for a simple architecture is shown in figure 1. It uses an instruction fetch or decode pipeline which process instructions in order. In the pipeline implementation of figure 1, instructions say stay in the sequential until the time they are issued. Furthermore, the process state is not modified by an instruction before it issues. This makes precise interrupts a simple matter when an exception condition can be detected prior to issue. To implement precise interrupts with respect to registers using the above pipeline control structure, and issuing instruction using state J should reserve stages I less than J as well as state J. That is, the stages I less than J that were not previously reserved by other instructions are reserved, and they are loaded with null control information so that they do not affect the process state. This guarantees that instructions modifying registers finish in order. There is logic on the result bus that checks for exception conditions in instructions as they complete. If an instruction contains a non-masked exception condition, then control logic cancels all subsequent instructions coming on the result bus so that they do not modify the process state. To implement precise interrupts with respect to memory, one solution is to force store instructions to wait for the result shift register to be empty before allowing them to issue. Alternatively, stores can issue and be held in the load or store pipeline until all preceding instructions are known to be exception free. Then the store can be released to memory. To implement second alternative, recall that memory can be treated as a special functional unit. Thus, as with any other instruction, the store can make an entry in the result shift register. This entry is defined as dummy store. The dummy store does not cause a result to be placed in a register file, but is used for controlling the memory pipeline. To To implement precise interrupts with respect to the program counter, the result shift register is widened to include a field for the program counter of each instruction. This field is filled as the instruction issues. When an instruction with an exception condition appears at the result bus, its program counter is available and becomes part of save state. That's it. Thank you. No, no, no. Implementing precise interrupts in a pipeline vector architecture is more difficult than for a scalar architecture. When considering precise interrupts with respect to vector instructions, preciseness must be carefully defined. Unlike the scalar instruction described thus far, vector instructions do not produce a single result and change the system state as they complete. That's it. Thank you.